Hi, I'm Evan Chaki. I'm the GM of AI Innovation here at Microsoft.
Hey, and I'm Shawn Henry. I'm the Group Product Manager for Semantic Kernel.
So today we're really excited to be here, and thanks for joining. You know, we have a lot to share. You're going to hear from multiple enterprises that are already live with AI, driving productivity for their employees and for their organizations. But before that, I want to dive a little bit into SK, Semantic Kernel, and introduce you to what we do. So Semantic Kernel abstracts away all these underlying SDKs from different AI providers, from Microsoft and other providers that are out there. We're fully open source, production ready, and ready to serve you whether it's in Python, Java, or even .NET. So this is the Copilot stack. You may have seen this. We really sit between the human in the app experience that they are in and the models below us. So we call into different systems, data, vector stores on behalf of the user to get that live content, to use for the models to provide that factual data, and to make sure that AI can take action on behalf of your users. So we built Semantic Kernel for enterprises, and in particular for enterprise app devs. So we knew that we needed a way for those users, for those professional developers, to quickly add AI to their applications. So now that you know where Semantic Kernel fits into the Microsoft story, let's talk about the scale of enterprise adoption, and we have a few announcements for you today. So all three kernels are all GA 1.0 plus, which means no more breaking changes. We announced .NET back in December, so it's almost been a year of .NET being 1.0. We have Python that we announced at Build back in May, and even Java. So again, you have the option based on what type of platforms and coding languages that you use. So it's been amazing to see the growth of Semantic Kernel and really that enterprise adoption. So a few announcements. We have 1.1 million downloads of the Python Semantic Kernel. We have 2.1 million downloads of .NET. And we've never announced this before, but we have over 1 billion requests from Semantic Kernel into Azure OpenAI models. So it's been really amazing to see the growth, and that's really based on you and your enterprises trusting Semantic Kernel to really help you on your AI journey. So we do have a few new announcements. So we've been listening to your feedback and really moving even more packages to GA. So we're announcing today filters are available in Python and .NET for GA. Our Open API package also available as GA for Python and .NET. And our memory package is available as GA for Python, Java, and .NET. So we're really excited to let you use those where you don't have to worry about any more breaking changes for those languages. And speaking of .NET, so .NET 9 now has packages from the Semantic Kernel code base to make it even easier for you and for AI service providers to quickly build connectors into Semantic Kernel and into the Microsoft ecosystem. So a few things that we've done is our abstraction layer is now part of Microsoft.extensions.ai. And from a memory provider standpoint, our memory package is now Microsoft.extensions.vector.data. So we're really excited to announce that. Thanks. Now, so let's talk about that last package, right? So one of those packages, vector data, makes it so easy for customers to pick the right vector store to store their AI workloads. So we've abstracted away all the details from each vector store so enterprises can focus on getting AI into the hands of their users. So let's take a look and see this in action. All right, so I have here, I'm going to load some files from our Learn site into in-memory vector store, so just running locally on my computer. So what I can do now is I can start to ask questions and get results back from that. So I'll ask, OK, let me chat with my data. What do I need to know? Hey, let's show me how to maybe construct Elasticsearch in vector store in C#. So it's going to go through in-memory, find that information, pull it back so I can see that, wow, that's directly from our repo. But we also want to build in trust and enable verification. So you can see that link down below. I'm going to click on that. And now here is my source data. I can see from our repo. It shows me exactly how to go do that. So it's exactly what I just got. Again, we want to build that trust for our customers. Okay, so I'm going to go and bring Greg up here on stage. So Elastic is one of our premier vector store providers. And Greg, there's a few things. I heard you have a bit of an announcement to share today.
That's great. Thanks, Evan. Yes, we do. So Elastic's proud to announce that we have a vector store connector now for the semantic kernel. It's available on GitHub. You can access it today. And we're really happy to work with the semantic kernel team.
Awesome. Yeah, that's really exciting. Maybe can you tell us a little bit more about that value and the scale of Elastic that you really bring to customers?
Yeah, absolutely.
Awesome. Thanks.
So Elastic is the most downloaded vector database in the industry. We've been around for 12 plus years now. And we started as an open source. We're developer focused. We were started by a developer. We've always kept that focus of API driven, developer driven, start with open source and interact with that. So people started using us as a storage system, as a search database back 12 years ago. And we've started with keyword search, BM25 type searches. And we've grown over the years to add vector capabilities to our system, but at the enterprise level, because our customers are storing millions, billions of petabytes of data. They're searching across that every day. It's private information. It has to be secure. It has to be accessible in milliseconds amount of time. So as we've grown, we've added more capabilities, and that makes us now the most downloaded vector database in the industry. But we have the full scope of enterprise capabilities that allow us to support our customers at the scale that they need to, with both security and relevance and speed for search. And we look at all three. We look at speed as well as relevance when a customer goes to search. So think of an example. We have one customer today, which is a U.S. automotive company. They use us for about 30 different retrieval augmented generation applications already, just in the last year, where they have both customer-facing, service and support-facing, as well as internal-facing applications that they can search through all their private information and find it. It's all been vectorized and able to search within milliseconds. So if you think a little bit about the history of Elastic, back in 2017 was really where we started with AI and really with basic machine learning, being able to do anomaly detection, look for, especially around, a lot of people use this for log storage. If you've heard of the ELK stack, that's Elastic, that's our open source. That's Elasticsearch, Logstash, and Kibana. That's our open source based platform that we've built off of the search AI platform that we've built around it. But we started adding the unsupervised learning and supervised learning techniques across the data back then, and started to do some AI operations, which helps site reliability engineers and people like that to be able to identify issues quickly and resolve them quickly. But then in 2019, we added vector search capabilities to our system. And just to mention, we also are the biggest contributor to Lucene. So Lucene, if you're familiar with Lucene, we're built around the Lucene storage, and we're the biggest contributor to that open source project as well. But we built in the vector search back in 2019. So we've had support for natural language processing, semantic search, and now vector search for several years. And so now, with the ability to build these retrieval augmented generations, the LLMs that are available, our customers are building retrieval augmented generation applications very quickly, and it's becoming a huge growth area for us at Elastic. And we've added the ELSER, which is a sparse model, encoding model now. So previously, first you could download your models from Hugging Face, install those. Now we work with the OpenAI API inference service, as well as our own proprietary sparse encoding model. Today, we're happy to start working with the semantic kernel team. We've been working together for the last few months, and it's been a great situation where we can fit into the orchestration framework as a native vector database.
Awesome. Thanks, Greg. Yeah. Thank you. That's amazing, right? Let's give it up for Greg from Elastic. Yeah, awesome. Thank you. It's amazing to hear about this scale. We've talked a little bit about how to use memory. We saw how to do some of those RAG patterns, but let's see it in action. So I'm going to take the code that we used earlier to go ahead and run that app. And what I'm going to do is over on line 42, we'll just see how easy it is to switch out. So remember, earlier I did the in-memory, so on my laptop here, doing those vectors. So what I'm going to do now is I'm going to go ahead and switch out to Elasticsearch. So we've taken all of our learned sites across Microsoft, put them into Elastic. And what I can do is, again, with 3 lines of code, just like you saw there, I can now go and my data has already been adjusted. I can ask, how do I get Elastic Stack on VM? And what's going on is now it's going to go pull that data, just like it did before, across a huge number of documents. And you see how fast that was. And again, I can go back to the source and see that. So really, really exciting to really let you leverage things like Elastic and certainly other vector memory providers. And we make that really easy to switch between the two. All right, so we saw some of that underlying technology that's available to help you begin your journey. To really make this impactful, you need to meet your users where they are. And really to do that, sometimes your end users are in social media platforms like Facebook Messenger or WhatsApp, and you need a way to bring AI to them so that way they can get work done, they can interact with you as a company in those experiences. So things like maybe Alexa, again, Messenger, WhatsApp. Other times, your employees are your peers, right, in enterprises. So you may have homegrown systems or systems from other vendors like Slack or Teams. With Semantic Kernel, we can actually enable you to build AI agents and deploy those where your users already live. And how do we do that? We do that with Microsoft 365 Agent SDK. So you may have already heard about these announcements earlier at Build. So now I can connect to any of those channels and allow Semantic Kernel to be that orchestrator for those calls. So that's pretty interesting. It's one thing to talk about what this looks like, but we're going to go ahead and bring up Hiro on stage from Fujitsu so we can hear how they're leveraging this type of technology to help employees in teams have more productive meetings. So Hiro, thanks for joining us.
Thank you very much for inviting me.
Can you share a little bit about what you're doing at Fujitsu and what that looks like?
Oh, sure.
Awesome, thank you.
Good morning, everyone. My name is Hiro, Research Director in Fujitsu Research of America. And today I direct the pleasure to talk about how we utilize semantic kernel for AI agent. I'm not sure how much you know about Fujitsu, but just in case, Fujitsu is one of the biggest ICT company in the world, and our business is about B2B. So it means we are talking to the customers and hearing their requests, and we are providing the good ICT systems for the client. So that's what we're doing. And it is very easy to imagine the recent request from customer is about AIs. So we need to provide the good AI technologies customers to the client. For that purpose, we have developed our own AI platform, which name is Fujitsu Kozuchi, and this is filling a gap between the R&D to product. And Fujitsu has many kinds of AI technologies, and we put all AI technology into this and provide that technology to the customers. And as you know, as everyone said, recently, everyone is keen about AI agent. And of course, Fujitsu does have the AI agents. So this is what I want to show you in here today. So I just give you some video first. Please watch out.
This is not the future. This is now. AI can already be a fully fledged member of your team. Here, an AI agent joins a regular meeting. It can read your conversations and make suggestions. And it shows you the information you need. Before you even know that you need it. Moving from reactive to proactive AI. Advanced autonomy enables new possibilities.
This video showing pretty much everything what I want to say, but let's say this is our visions in the very, very near futures. So it means that I'm for sure you are utilizing the Gen AI already for summarization or maybe some translations. Of course, I am using. But for that interaction, it's a kind of a one-way interactions. You need to ask Gen AI, then they coming back to you. But very, very in the near futures, that interaction will be changed to the proactive interactions. So as you watched in the videos, our AI agent doesn't need any the request. AI agent will understand what should I do now, when should I do now. So such kind of interaction will be changed between the human and the AI very soon, and our Fujitsu Kozuchi AI agent is implemented by Semantic Kernel. So I'd like to briefly show you how to create the AI agent with the Semantic Kernel in this slide. So actually there is two parts. One is the listening part, and the other one is the proactive part. First, as you can see, there's the numbers, and you can see 1 and 2 is a kind of listening part. So through the online meetings, AI agent will store the listening part into the memories. Once it's stored, the task agent, task generator will works independently. Means it's checking the memory periodically and try to create a good tasks for the conversations. And once we create it, it's number 3, the tasks will pass the planners, and the planner goes to the AI agent again, and the tasks will be decomposed into the 2 subtasks in these cases. For example, the one task is about the data manipulation, the other one is for the visualizations. And based on the subtasks will be assigned to the tool use, and you can assume this is a kind of a sub-agent inside of our agent. And that tool use will utilize the data in a data lake, and the tools in the tool lakes. And sometimes our sub-agent will produce the Python program, and that Python program will be executed in the code interpreter as the sandbox. So it's a secure environment. And once everything finished, the request will be converged into the one, and it's passed back to the client. This is pretty much everything what we're doing, and as you can see, there are so many semantic kernel functionality in here, and we are pretty much utilizing and make our implementation very efficiently. That's all from my side.
Thanks, Hiro. That was great. Yeah, I love it when our partners can take these really sophisticated solutions and make them available to their customers where they are, like in this case, in Microsoft Teams. So I want to talk a little bit about agents. Have any of you guys heard of agents? Anyone talked about agents at all? This conference, raise your hand if you've heard about agents. There we go. Okay, good, good. The rest of you have just got here, maybe? All right, because last session of the conference, so it's the last time you hear about agents for a little bit, except maybe on the way to the airport. So, what is an agent? Let's just kind of start at the beginning with a nice generic definition of what agents are. So an agent is an actor that uses one or more models and allows you to do complex, long-running tasks that can take action on your behalf. So let's break that down. To me, what that means is, it's a process that has a job to do, a job description, has a set of tools to accomplish that job, and has a set of tasks that you give it as part of its job that it will use the tools to accomplish. Now, for our developers here in the audience that are already using Semantic Kernel, this should sound pretty familiar. You've been using prompts already today with Semantic Kernel. You've been using tools and plugins and APIs. And you've been giving your Semantic Kernel applications tasks and configurations to do. So guess what? You've already been using agents for the last couple years if you've been using Semantic Kernel. But in Semantic Kernel, we also have an object model that abstracts this all away for building agents in Semantic Kernel. We released this about a year ago. We have tons of customers using it already. In fact, you heard Hiro using the word agent a lot in his talk. And Also, if you've been attending some of the sessions on Azure AI agents or Microsoft 365 Agent SDK, you'll hear them say the words when they're doing their demos. These demos were built on Semantic Kernel because we've been doing agents for a little while. I'll give you some examples. So when you're building an agent, you kind of think of a task you want to do its job. Here's an example of a GitHub agent that retrieves information from a GitHub repo. You give it a tool, in this case, a GitHub plugin. Maybe that's an open API spec for talking to GitHub. And then you give it a task. Go to the Semantic Kernel repository and get the latest information. Maybe you have a nice constrained agent that checks the weather, builds an adaptive cards out of it. So its job is to output adaptive cards, nicely formatted JSON from adaptive card. You can give it a validator to make sure that it's always outputting JSON that can be rendered. Give it access to a weather API, and then give it access to a time API so that you can ask it things like, what is the weather in Chicago today? We have a couple different kinds of agents in Semantic Kernel. We have our kind of chat completion-based agents, which can be used with almost all types of LLMs. You can give it instructions, and then you can attach state to it, the chat message history. You can attach storage to it, the vector stores that we talked about earlier. And you can give it tools and APIs that can use to accomplish its task or job. We also have assistant-based agents, which are similar to the API that Azure AI Agents is giving, where there's an attached state. The state of that chat history is associated with the agent for you. There's a vector store and storage associated for you with that agent. And there's a set of tools for things like executing code or doing a web search so that an agent can use those tools to accomplish its task. Finally, in Semantic Kernel, we also support multi-agent scenarios. So you can create multiple agents. In this case, we have a copywriter agent that is going to generate some slogans for us. And then we have an art director agent that's going to look at those slogans and give it some feedback. And if we give these two agents user input, ask it to come up with a slogan for an electric car, we can put those agents together in a group chat object. And they'll go back and forth, and they'll converse about what the best kind of a solution is, and they'll get some feedback. The agent number one, the copywriter agent, is proposing some possibilities for a new slogan, and the art director agent is critiquing it, and they'll go back and forth, and eventually they'll converge on a solution, and that'll all get approved. So you can build all these things with Semantic Kernel today. And to talk a little bit more about the tools that we have to enable you to build these things really quickly, I want to bring 𝗦𝗲𝗀𝗀𝗻 up here from ServiceNow.
Hi, everyone. My name is 𝗦𝗀𝗀𝗀𝗻. I'm from ServiceNow. I'm the Director of Innovation and Research. A few weeks ago, we had the opportunity to work with the Semantic Kernel team to work on a collaboration project. Did I click something wrong?
Is it working? Oh no, you're showing my agents again. Time here. All right.
All right.
You ready?
There you go.
This one here.
Thank you.
All right.
So ServiceNow is the AI platform for work. And we already have our AI capabilities, and we have Now Assist in ServiceNow already integrated with Copilot. So let me start with today, our user is already able to call upon Now Assist in Copilot on Teams, not only to retrieve information, but also to execute tasks, such as find out information from your knowledge base articles, and also create incident and tickets in our ServiceNow platform. But we're not stopping there. We want to push the envelope even further. I want to find out, what does it take to bring these two awesome AI assistants together to not only provide one-off, handing-off executions, but also sit side by side with our human team to complete critical tasks, not only the mundane activities, and with the common goal. So we picked a use case, which is a P1 incident resolution call. I don't know if anyone have an experience of what does a P1 incident looks like. That's right. It's hour-long, very intensive call with a lot of spoken information and very little documentations. You have people hopping on and off the call all the time, trying to figure out what is the current status. what the team has already been done, and what you will be going to do next. Those informations are poorly captured, and as a consequence, there's very little information to help us to create knowledge articles of the resolution for future remediation. But we also see a great opportunity here. The live transcript and the action extractions are working so well today. And we are also having extensive AI capabilities ready to be used from both ServiceNow, Now Assist, and also capabilities like Copilot. And not only that, the reasoning and the planning capabilities are also getting mature. Look at what Semantic Kernel and O1 models could already do. And all of the above are only getting better every day and cheaper every day. So let's look at what the team was able to accomplish in a couple of weeks.
Put AI to work. A better together story between ServiceNow and Microsoft. This is Bailey, Senior Manager of our Major Incident Management team. Today, a critical incident is being reported. For high-priority cases, online meetings are automatically set up. Participants could join directly from Microsoft Teams or via the links on the ServiceNow platform. The participants start to debrief the case. There's also an explicit request for 𝗦𝗽𝗻𝗀 to help.
𝗦𝗽𝗻𝗀, how many users are impacted?
𝗦𝗽𝗻𝗀 create a LLM-based query for the data in ServiceNow instances and get the result back for the team. Due to large number of impacted users, the incident need to be escalated.
𝗦𝗽𝗻𝗀, update priority to P1 and update the assignment group to Security Crisis Management on call.
The actions being discussed in the call are being automatically captured, and the incident is now updated as instructed by the team. The team suspected that the root cause could be related to some recent configuration changes.
𝗦𝗽𝗻𝗀, rollback the change request 0449530.
𝗦𝗽𝗻𝗀 could help the team to get the necessary approval and roll back the changes. The actions and updates of the incident are in sync whether you are on Teams or on the ServiceNow platform. With the help of 𝗦𝗽𝗻𝗀 and Copilot working together, the team could quickly get the incident resolved. After the case closure, 𝗦𝗽𝗻𝗀 will work together with Copilot to generate report communication and knowledge base article based on the resolution for future remediation.
That's right. So with this proof of concept, we were able to deliver a couple of things. So first, we have created a manager agent leveraging Semantic Kernel that is orchestrating not only the activities between Copilot and Now Assist, but also human actions. And so that we can meet our user where they are and also provide a single source of truth of the overall incident status. And we're not stopping there. We're barely scratching the surface here. Our team will continue to develop our domain-specific and domain-aware cognitive architecture, and we'll keep expanding our action and agent catalog, and also keep iterating and reflecting on what the user interaction should look like, what the human is expecting when they're interacting with agents and multiple agents, internal agents, but also external agents, and what are the guardrails we need to put into place to protect this trusted relationship. If we step back from this use case and think beyond what is going to happen next. So today, if we want to conquer those difficult activities, those challenges, we want the agents to be able to work together. We also need to help them to be grounded with customer-specific data. And today, we already have those insights and workflows sitting in the ServiceNow instances. And our vision is to create an open and collaborative framework that can leverage awesome workplaces and collaboration tools like Teams and also Copilots, but also to enable the creation of native agents, helping our client to embrace third-party agents, agents that are created in-house, and also agents that are created by Copilot and also Copilot Studio and Semantic Kernel. So if you're interested in this collaboration, let me know. I'm happy to talk. Thank you very much.
Thanks, Wajin. That was great. I think it was only about like a month ago that we got in contact with their team. Evan and I gave you the pitch on Semantic Kernel, and then it was like 2 weeks later, we get this call. We got something we want to show you guys, and they showed us this. It was really great. I love how quickly you guys were able to be successful with Semantic Kernel. Thank you.
Using it.
But it's not just about building proof of concepts. Semantic Kernel is really about bringing your apps to production and scale. So actually, right away, I want to bring up another partner here. Urko, if you want to come up to talk about your experience with Semantic Kernel at Centauri.
Hi.
Here you go.
What's this, the button?
This one right here.
Okay. Okay. So, well, looks like we are the only non-tech company here. My name is Urko. I work for Centauri. We make spirits. The use case that we will show you today is how we can help our sales rep to prepare this visit when they are trying to go to the location, and we call this pre-visit summary. So we just created a landing application, which is a simple Power BI. The goal of this Power BI is to help our sales rep to select the bar that they want to visit. And when they select the bars, then is when Semantic Kernel kicks in. Before the demo is loading, I will explain what is happening on the background. So we are loading information to Semantic Kernel, like public information, like online menus, user reviews, and also private data, like SAP Sales, Salesforce, using open plugins. All this information we are loading in the memory and helps us to prepare the system. So during this time, we use all this information and open plugins to give the ability to Semantic Kernel. So the first thing that our sales rep will be doing is, after selecting these two bars, is, OK, can you give me a summary? Can you give me a summary of this two bars? And the idea is Semantic Kernel will be going to using open plugins and going to the data that we have, the menus, the online website, and also Salesforce or SAP data. And will be giving me a summary of these two bars. So now I have a good idea of what this bar looks like. And the next question that I will just to ask to the agent is, OK, how can you help me to introduce a new Centauri brand in these two bars? And this is what I'm asking here is, help me to identify which are this new product that we can introduce. So Semantic Kernel, again, is going to our product catalog and getting the information from the bar will be just trying to give me what is the best idea or product that we can provide to this bar. So that's perfect. But how can I position this? How can I create a story that I can tell to the bar owner? And this is what I'm asking right now is, can you give me an ideas or help me to try to create this story? And Semantic Kernel will be going to our brand strategy, to our product, and now we have more data because we have the chat history, and everything is given this. So we look that we have drink preference. For us, drink preference means cocktails. So let's focus that. Why we cannot create a new cocktail menu based on that? And this is what we are asking right now. Give me cocktails that for this two bar can help me to introduce new brands. The system will be going to our cocktail catalog using the bar type, all these things that knows, and prepare me a super new cocktail menu with the ingredients, with names, and everything, which looks amazing. As a sales reps, yes, there are a lot of things here, but I will say, OK, can you clean it up for me? Because can you prepare something that can help me to create a story that I can go to the bar owner and say, this is the reason, or that's are the ideas. And this is what I'm asking here. Can you clean up for me? I think right now it's not using any open plugin, and it's using only the LLM power to resolve the question, but maybe we have something. So the reason is that we are creating this story to help our sales reps with this introduction. So we see that it's creating a new email draft. So, but I remember that we have not asked for price. So maybe this is something that I can ask. Can you give me a price range for this product? And then can I prepare the full story? So this is what we will asking. Based on this location and the product that we have, can you suggest me price for these cocktails? And the system will look where these are bar located, what are the competition are doing, and will be providing a range of this price. So this is one of the use cases that we use for our sales rep and how we use Semantic Kernel. This is one use case of one of the agents that we have. We have multiple agents in one platform that we call 𝗬𝗲𝗄𝗏. We just released it internally as a beta preview for 300 members of our company, and we hope that we can do the GA available or general release in 2 weeks from now. And let's cross our fingers that everything goes perfect. So back to you, Shawn.
All right, thanks, Urko. I don't know about you, but I'm thirsty after listening to all that. That was great. That was great. OK, I want to finish off with one last thing, one more thing that I think is going to be really great, some new stuff that we're working on the Semantic Kernel team about business processes and AI. So it starts with, Evan and I and the rest of the team have been talking to our customers, hearing stories from our friends about how they're building and using AI inside their enterprise. And there's this similar theme that they're all searching for this AI productivity boost. They're trying to find leverage with AI within their business. And they typically start in the same way. They kind of look at these kind of talk-to-docs patterns, RAG search, Q&A bots, those kind of things. Or they have talk-to-data where they're looking at some internal data and trying to generate graphs or some analysis on top of that data. And they find a lot of success with this, especially with Semantic Kernel. And kind of the next step is in a lot of cases, they'll take some of these and they'll kind of do their B2C use cases where they'll build chatbots on their application, chatbots on their website so that their customers can do some tech support. And that's great. We're seeing a lot of customers being really successful with that. And then from there, they start saying, well, OK, what's next? What are some more advanced things I can do? They start building on agents, multi-agent systems, some of the examples that I showed you earlier. And that's great. That works pretty well. But there's cases where either a multi-agent system doesn't work because the agents don't converge on a solution. They just keep talking forever, and they never kind of come up with an answer. Or sometimes it's just not the right problem for agents, or even for the process. It's not even some of the steps in the process. It may not be the right thing for AI to work on at all. And so we see these kind of business processes with AI, these customers that come back with these kind of more advanced, longer running processes that they want to use AI for, but it's not really a right fit with just agents. So to help with that, we're introducing the Semantic Kernel process framework. And what this is, our goals with the process framework were to kind of allow all our developers and customers to leverage all the existing SK investments they have around building things within the Semantic Kernel, using Semantic Kernel, but allow them to collaborate with their peers that already have business processes running within their enterprise, and to use AI to enhance and streamline the steps in those processes in a controlled, defined, and repeatable way. These are the things we heard from our customers, and this is what we wanted to build with the Semantic Kernel process framework. And this is made up of kind of 3 main constructs or things to think about. One is the process. This is the overall process that we're trying to build. Steps within the process. So within the process, you have multiple steps. Those happen in sequence. They can move around between different steps, different orders. You can map, you can reduce, you can do all sorts of things with those steps. And then patterns, which is the actual sequence that those steps are executed in. So where does this process framework kind of fit in with the larger semantic kernel story? Well, we see this kind of this overarching thing that can be used to manage your business processes. And parts of those steps in those processes can use the agent framework. You can have agents in those processes. You can have multiple agents in those processes. Those agents can collaborate together to come to a solution. You can have just regular semantic kernel code that uses models and services and prompts. In AI, you can just have regular code. You can connect it with the code that you already have in your enterprise that you're using to work with your business processes. And you can put humans in the loop. If there's parts in your step where you want to have humans, people that are actually verifying, validating, or moving, doing parts of the step, you can have that as well. So let's finish things up. We kind of reimagined a customer experience end-to-end using the process framework, and I wasn't kidding when I said I was thirsty. We were kind of thinking about what we would do, after this session is over, the last session of Ignite. I think we all want to go out and have a little party. So we thought, what would a business that was kind of a sales business for refreshments, maybe some of these great Centauri drinks that Urko was talking about, what would it look like if you were a business that was kind of arranged that? And you would have these kind of steps. And let's kind of break this down. Let's look at kind of what those first couple steps are.
Hello. How can I assist you today? Are you planning a party or looking for some great drink options?
Yeah, I'm planning a party for about 250 of my best friends. I wonder if you could help me put an order together.
I'd be delighted to help with that. Could you tell me how long the event will last and where it will be held?
Yeah, it's going to be like a 3-hour party. So I'll just skip ahead a little bit there. Let's talk about what we saw. So that was a very simple website, using the real-time audio APIs from OpenAI to have this kind of natural conversation with the customer that I could interrupt, that I could have this really fluid conversation with. And it was gathering data from a vector store. We talked about memory earlier, and kind of pulling data from vector stores so that it can kind of know about the products that it can talk about. And then filters, we can use things like Prompt Shield at the front end of the process to really filter the kind of things that the customer can talk about with the agent. And then the next step in the process is kind of the order creation. So we take that transcript of the text between the user and the bot, the agent, the real-time audio agent, and then we convert it into an order. In this case, we're using a multi-agent system to create the order, then validate the order, and go back and forth until we have a good order. And then we connect via OpenAPI to our data store. And our agents know about that. They can just ingest the OpenAPI manifest, and then they can use that in their process flow to talk to our database. Now, let's go to the back of the house and see what's happening.
Hi, I am Bo, and I work at Tailwind Trader as an event advisor specialist. I review high priority orders. See one that just came in that I need to review. Luckily, a card is created for me with an overview and a link to the template I have to fill out manually. But today, IT rolled out AI into Microsoft Word that pulls data for me. Rather than logging into the core system and manually copy over the order details, I heard I can just ask it what I want and it will get the information for me. It looks like I can just click on Format Orders, and I can enter in the order number. Wow, it just pulled the data from our core system without me having to log in, search for the order, and then manually enter in all of this information into the Word template. That just saved me about 15 minutes, and that is on one order. I will email the customer the link and get this order processed. Thanks, AI.
No, not thanks, AI, thanks Semantic Kernel. So what did we see there? So we saw an adaptive card get created by an agent. I talked about that a little bit earlier. This is an assistant-based agent that has all of those components associated with it, some state and some memory and some tools that it can use to generate those adaptive cards. We have a human validation step where that data actually shows up in Microsoft Word. The semantic kernel agent can process that information and have it show up in Copilot on the side in Microsoft Word. And then the sales agent can take that and then send that right back to their customer via email using a Logic Apps plugin. Okay, so that kind of wraps up a nice little process. Semantic Kernel process framework went into preview in September, and we're getting a lot of good signal from our customers that they really love it. Please try it out. It's available, and we think it's great. Probably the best thing since agents. All right, Evan, you want to take us home?
Yeah, thanks. Thanks, Shawn. Let's give it for Shawn. Thanks. So a couple key takeaways, right? You've seen how Semantic Kernel is enterprise ready, all 3 languages. We have the additional packages now for you for GA. You also can take advantage of those vector stores like we saw from Elastic, right? With M365 Agent SDK plus Semantic Kernel, you can meet your users where they are and deliver AI to them just like Fujitsu is doing. With the agent framework, we allow you to create AI agents that, just like we saw from ServiceNow and Centauri, and again, GA for agent framework is going to be coming in early 2025. And the process framework allows you to create more deterministic AI workloads using agents, code, and plugins. All right, so a few things we need to do. What's next? Explore SK. We have notebooks to get you started. And today, if today's your first day, it's okay. Now's your time to become an AI champion. Like you saw here, we can't wait for you to get involved and have you up on stage with us next year. So thanks again. Thanks for joining. We even have some posters out as you leave, so that way you can get started today with Semantic Kernel. Thanks.